Okay, good morning. We're recording. All right, so happy Thursday. And all right, last day. Oh, yeah. I'm actually surprised I only had one person reach out and ask me about the assignment that was supposed to be due yesterday, or sorry, due today. I bumped it till next Thursday because we actually hadn't covered a lot of it. So it was really, really hard. You have all the information that you need to be able to piece it together, but it's just really hard. I don't expect you to do that until we've covered some examples on it. So assignment number 5. Assignment number 5 is now due on I bumped it to Thursday, March 11th. Moved my calendar to down here. Okay, yeah, so of course at 11:59 p.m. as always. So after today, you'll be able to do all of it, right? Or kind of the majority of it. So after today, you will be able to do all / the majority of it. I just don't know how far we're going to get. Okay. So last day, just as a quick review, and like I said, I have a little note to myself saying we didn't finish example 147, so we should probably do that. But just as a little review before that, we introduced the future value is P times 1 plus R times T, right? Where the future value is actually P plus the amount of interest, right? And so where the future value is the principal plus the amount of interest. The principal and capital I is the amount of interest. We need to keep these variables straight, right? What is capital I? Well, when I say that, it's the amount of interest. And of course, the future value is, the future value is the total at the end of the term, and the term is the time t in years at some rate r, right? And so we worked through and we used this formula to find the future value given some information, right? Given p, given r, and given t. And then we also solved for p, right? So we were able to solve, okay, what amount do I need to invest today in order for it to grow to $5,000, for example, right, at some interest rate and some amount of time. And so today we're going to finish an example where we're calculating multiple future values, or was it present values? No, future values. And then later we're going to solve for what rate would make this happen, and then how long would it need to sit there for all these conditions to come true. So come true, magical. We didn't finish, so example, and I'll just kind of end the review here. Example 147 continued. Okay. So just kind of what I'm going to do is, because we'll do more where we have to draw a timeline and stuff like that. So let's just remember what we did here, and I'm just going to grab all of this and bring it in. This is just from last day, right? So paste image. Otherwise it'll go all wonky. So this is all the stuff that you presumably have in your notes already. Oops. Okay, so let me bump this down here. All right, so what did we do? We said, okay, well, we read through the problem, of course, and then we identified the dates that are going to be our dates on our timeline, and then we space those out on our timeline, and they don't have to make sense, right? They're just for visualizing what's happening. So then if we're talking about loans, and you think about a loan, so if she borrows money, $2,200 on June 23rd, then of course she's going to have to pay back more, right? The $2,200 plus interest, right, on December 31st. So each of these loans are going to act kind of independently, but they're all going to go to some future value. And usually I just kind of take my fingers and I just draw them, and I that way I know I'm going forward, so I have to find the future value. In general, right, whatever is on the left of the arrow is going to be the present value, and whatever is on the right of the arrow is the future value. Okay, so here I'll make a note kind of in between here that in general we have the present value, or P, goes to the future value, right? So P is on the left and the future value is on the right. And a lot of people have a hard time with that, right? Where's my present value, where's my future value? The principal / present value is what we're going to call it later. I have no idea why we don't for simple interest, but that's okay. And then this is the future value, right? So if you get that relationship kind of ingrained, then that's a step in the right direction. Okay, so this P, 2,200, grows to some future value, and I've called it future value 3 to be able to distinguish between each of these. Now notice the rate for all of these is 0.0725. That's not necessarily the case, right? It would be from the question here, but 7.25% was charged on all 3 loans. So that's going to be our R for all these calculations. And all of them are being repaid on December 31st. So we need to figure out, okay, what is the 1,300 plus interest? What's the 1,800 plus interest? And what's the 2,200 plus interest? Noticing that they've been in there for different amounts of time. So we started and we said, okay, I need to find the amount of time. And when I have specific dates, I have to use the days between dates calculation on my calculator. So we set that up and we said, okay, so we need to find the days between dates. And I had them kind of squished on the same line, so I'm not scrolling so much. Date 1 has to be your first date, and then the end date has to be date 2, and you have to have them in the form of month, dot, day, year. So keeping track of what you're calling T1, T2, and T3, right? Because you're gonna have 3 different times. Notice that each of these have a different length, of course. And so I have T1 is from October 31st to December 31st. You want to really kind of keep an eye on that you're doing it for the right one. Otherwise, your calculations will be off, right? And so T2 is going from August 5th to December 31st, and then T3 is going from June 23rd to December 31st. However you set these up, just kind of develop your own rhythm. I always just draw my arrows starting at the closest one, and so that's why they're labeled like this, but it doesn't matter. So let us use our calculator to find all these days between dates. Now, I am going to, maybe I can remember them. Okay. So what we said was that date 2, once I've entered it once, I don't actually need to change it until it changes. And for all of these, it's the same. So the only thing I need to go in and change is date 1 for each of these. So let's find the days between dates for October 31st to December 31st. Notice that I still use a little asterisk to indicate that, hey, this is the one that I've calculated on my calculator, right? So I gave it this and it gave me this, and that's what I'm going to be using. So I use a little star to indicate that. So if we go to your calculator and power restoration updates, cool. Okay, so remember the date function is in the second menu above the 1, and so we're going to go second date. And we have this June 26th date as our date 1. That's not the one we want. In fact, I want to start with October 31st. So that was month, so 10.3120. I think we decided to use 2020. We need to hit enter. Notice that it's in this weird format, so you have to hit enter, otherwise it won't store it, right? And so you might think that you've entered it, but you haven't stored it, so then it just defaults to whatever it was before, which would mess things up. So you want to check to make sure that it's showing up properly, and then we'll scroll down to date 2, which is going to be December 31st, so month, so 12.31, and pretty sure we said 2020. It doesn't specify, so I'll just use 2020. And again, I'm going to hit enter to store this in date 2. And then I'm going to scroll down, and it's got my old days between dates, so don't be confused, because you have to hit compute, so you have to tell it what to do. So it's not a very clever calculator in the sense that it just anticipates what you want to do. You have to tell it, okay, now I want you to compute, which is that CPT button in the top left-hand corner. So there are 61 days between those 2 dates. So I'm going to jot that down. So here, I've got 61 days, but T has to be in years, right? And so when I write the T1 here, I've got 61 divided by 365. That's going to be your T, right? In years. And we assume that we have 365 days in every year. Okay, so now what I want to do is I want to do the same thing, but I have to change date 1 to be August 5th, 2020. And I'll find the days between dates. So I'm going to go back to my calculator here. And I actually don't need to exit out of the menu. What I can do is I can just scroll up to date 1. And then I'm going to change it to August 5th, I want to say. Yeah. So 08.0520. Have to hit enter. And make sure you're putting it in date 1, right? You don't want to change date 2. And then I'm going to scroll down, make sure date 2 is still December 31st. It is, so that's good. Then I can scroll down and I can compute the days between dates. And now I'm at 148. Right? So now I can jot that down. Okay, 148. Oops. As a mental kind of check-in note, I want to make sure that, okay, when I put down 148 here out of 365, 148 is longer than 61, right? You you just want to make sure that what you're saying makes sense. So then 148 out of 365. Okay, same thing with T3. I'm expecting it to be quite a bit longer than 148, right? June is before August, so okay. So I'm going to change it to June 23rd. Date 1 becomes June 23rd, and date 2 has to stay December 31st. So again, now I can scroll out to date 1 and change it to June 06.2320. Enter. Make sure it stores it, and then go down. Okay, it's still December 31st. That's good. And then I need to compute the days between dates. So CPT, I get up to 191. So now I have 191 days. Which I can add on to T3, 191 over 365. Remember, you have to divide by 365, otherwise all your future values are going to be huge. 191 years, yikes. That loan would blow up. So now I have my times, right? And it looks like my timeline is complete, right? I've got my dates up above, my dollar amounts for each of those dates below, and then I've got arrows showing the time with the amount of time on the arrow, and then just kind of somewhere around there, I jot down the rate just so I have it. Okay? And then here, notice that this gives me a roadmap for things that I want to solve for, right? So now I have to solve for the future value 1, 2, and 3, and then eventually what I'll have is I'll be able to add those up, and that's the total owing on December 31st. So kind of historically, this is the type of question that we get you to do for on the final exam for simple interest, right? So using the days between dates calculation and finding either a future value, or what we'll see later is maybe we have to find the present value, right? But the idea is the same. So you have to start with a timeline, and the timeline, really notice how much work this is, right? And so in terms of marks, a lot of your marks are going to come from your timeline, right? Not necessarily your final answer. If your timeline is good, your final answer will be good. Right? The math is not hard, but it's setting this up and kind of deciphering what you're given that's hard. So now I can solve for, okay, I know the future value in general is P times 1 plus R times T. So now I have all the information that I need to be able to solve for the future value 1, for example. The future value 1, and you will want to refer to your timeline here. Future value 1, right? Just make sure that you use the right P. P is 1300 and T is 61 over 365. Right, so just make sure that you grab the right information that corresponds to your future value 1. Okay. So, and now I scroll, 1300 is P, oops, times 1 plus, and then R for all of these is going to be 0.0725. And then T for future value 1 is going to be 61 over 365. Remembering BEDMAS, right? You have to, so how I do this is I simplify 61 over 365 and then I multiply by 0.0725. The order here doesn't matter, but you do need to simplify this lump first before you add it to 1. So that's going to be really important. So to show that in my work, I'm going to do 1,300 times 1 plus, and then because the going back and forth between the calculator on the screen is kind of tricky, 61 divided by 365, I'm just going to do it on the side here, times 0.0725 puts me at 0.0121164386. Correct me if I did that wrong. Might have gone too fast. Right, so to show in my work that this is, I've simplified this first and that becomes this before I add it to 1, that's how I show it, right? And then now just keep all these, because you want to keep all these decimal places. We are talking about money, so it's kind of important. So keep all these decimal places and then add it to 1, which you can just do while it's on your screen, right? And then multiply by 1,300. So I'm going to try to, so usually I would show that next step too. 1,300 times 1.012, blah, 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 blah. But what I'll do is I'll try to keep it nice and short here and just multiply by 1,300 right away, putting me at 1,315.75137, which, if we're talking dollar amounts, right, we should round to 2 decimal places, so we get 1315.75. Okay, now we do the same thing for future value 2. Right, and so I do the exact same thing. So after the timeline is set up, the calculations are just tedious and we just need to do them. They're not hard, you just follow the same procedure over and over again. So now the things that are changing are, for future value 2, they're changing, so the P, the present value or the principal amount is 1,800 now, so that's going to change. And T is 148 days, right? So 148 over 365. Other things like R stay the same. There's only one other thing. So future value 2 is, no, I lost it, 1,800 times 1 plus 0.0725 times 148, over 365. Same deal, right? I'm just going to emphasize that I'm simplifying this chunk first, the 0.0725 times T, and then adding it to 1, and then multiplying by 1,800. 0.0725, you can do it in any order, times 148 divided by 365 is going to be 1,800 times 1 plus 0.02939726027. Of course, it keeps going, so I'm just going to keep it in my on my screen. Plus 1 on my screen, and then times 1,800 puts me at 1,852.915068. As a dollar amount, that's 1,852.92. I want you to get in the habit of making sure that your answers make sense, right? Does this make sense? Well, it looks like, okay, I borrowed $1,300 and then I have to pay back $13 or $1,315.75. That's a little bit more than what I borrowed. That makes sense, right? If you ended up at $1,000 down here, then something went wrong and you should go back and check your work, right? So just having that that kind of mental note of like, okay, the P has to be less than the future value, right? And so, okay, is this reasonable or not? I could also ask you things like, how much interest did we pay? right? And so maybe we'll add that on to the end of the question, right? How much interest did we pay in total? Things like that. So same thing here, 1800 grew to 1852 seems reasonable, right? Kind of same ballpark, but a little bit more with interest, right? So, so let's do the future value 3 is, so we borrowed future value 3, we borrowed 2200 for 191 days at a rate of 0.0725. So let's jot that down, 2200, oops, times 1 plus 0.0725 times 191 over 365. So you really want to follow along and make sure that when you calculate these, you actually end up at the same answer that I do, right? So 191 divided by 365, remember you can do it in any order, times 0.0725 puts me at 2,200 times 1 plus 0.03793835616. And I'm going to add the 1, and then I'm going to multiply by 2,200. So again, just as I expected, this is close to 2,200, but slightly higher with interest, right? So it's 2283.464384, which in terms of money is 2283.46. Okay. So now we need to go back and we need to check our timeline, but maybe also check the question itself, right? Because the timeline is supposed to reflect what we're supposed to do to answer the question. But also just make sure what total amount was required to pay off the loan. Well, that's going to be future value 1 plus future value 2 plus future value 3, which is what we've shown here by showing a little addition and then the total owing on December 31st. So the total owing, I'm going to show just adding those up, and then I'm just going to plug in what I found. So the total owing is future value 1 plus future value 2 plus future value 3, which is 1315.75 plus 1852.92 plus 2283.46. And you can and probably should use the rounded values here. I know I'm kind of bouncing around, but it depends on the situation, right? If you have multiple loans, then they should all be rounded and paid off individually, right? So now I'm just going to add these up, 1350.75 plus 1852.92 plus 2283.46. I get, I'm just going to make sure here, I get total owing of $5,452.13. What if I asked you how much interest did she pay? How much interest did she pay in total? How much interest did she pay? Oops. In total? Well, so the total owing is that $5,452.13, but she only borrowed the 2,200, the 1,800, and 1,300, right? And so the total interest, so the interest would be the total owing minus the total borrowed. right? If we had to kind of figure out how to write it out like that, it would be the total owing minus the total borrowed. And so the total owing is the 5,452.13. And the total borrowed was, first she borrowed 2,200, then she borrowed 1,800, and then she borrowed 1,300, which is 2,200 plus 1,800 plus 1,300, 5,300. So 54, 52, 13 minus 5,300. She paid $152.13 in interest. Right. So you can always arrive back at the amount of interest. And so that's why I said at the beginning of this chapter that the I equals PRT, although it's the first formula that we introduce, it's actually going to be obsolete in like a matter of days, right? And so we can always find the amount of interest if we have the future value and we have the principal amount. So we don't really need that formula. Sometimes it's easier, but for the most part, we're just going to use this future value formula. Great. Okay. So in the next section, we're just going to work through and I'll just show you how to solve problems where you have to solve for the rate and then solve for the time. They're going to be very similar, right? And so in section, because I think I just started this page here, 4.5, the rate of interest, which I'll just emphasize is R, and term of investments, which is T. So we'll start by solving for R and then we'll move on to solving for T, but you'll see that they're very similar. So if we have the future value is P times 1 plus R times T, if I ask you to solve for R, the same procedure, you would always use the same procedure for all of these calculations, right? So whether you want to have it kind of derived like we're about to do and then just kind of use that R formula if you ever had to solve for the rate, that's fine. Same thing for T. Once we have it established and you're able to show it quickly, then you can reuse it. And as long as you're able to show me once how you found this general formula for R, like I'm about to show you, and then you can just use it. So if we start with our general formula here, I'm just rewriting it. And I want to solve for R. I always imagine holding R steady. So what do I need to do to kind of shake? So I just have R on its own. Well, the first thing I need to do is I need to move this P over to the left-hand side because it's multiplying and it's holding those brackets together, right? And so I need to divide both sides by P. So this becomes the future value over P. And now that I've moved this P, I don't need these brackets anymore because they're not holding anything together anymore. So now I have 1 plus R times T. Okay, so now I need to solve for R, which means I need to get RT on its own by doing what? I need to subtract 1 from both sides. So we have the future value over P and then minus 1 equals R times T. Making sure that you have this minus 1 on the outside right? So if you want to, you can even throw some brackets around there. I'm not going to for kind of simplicity's sake, but if it helps you visualize that FV over P is one thing and then -1, then do it. Okay. These few steps are the same whether we have to solve for R or for T. Right now we just make the decision, okay, if I'm solving for R, then I need to divide both sides by T, right? And if I'm solving for T, then I would need to divide both sides by R, right? And maybe while we're here, I'll just solve for R and then for T. Let's just get them both out of the way right away. So here, solve for R, and then over here, we'll solve for T. Right. Same steps up until that point. Well, solving for R, I need to divide by T, so this becomes the future value over P minus 1, all divided by T equals R. Okay. Which I'm going to simplify this just a little bit, not simplify, but I'm going to condense it a little bit by writing the FV over P on one line, and then just make it a little bit smaller, so to speak. And so R becomes the future value over P minus 1 over T, right? Just kind of condensing it a little bit. And I'll put a box around this because we're going to end up using this. It's not on your formula sheet, so you might want to add it on your formula sheet. And then solving for T, right? Starting here at R times T, well, if I'm solving for T, I need to divide both sides by R. So notice that it's going to look very similar, except R and T are going to be swapped out. So here it becomes the future value over P minus 1 over R is T, or if you want to condense it just slightly, then T is the future value over P minus 1 over R. And again, I'm going to put a little box around this because it's not on your formula sheet, but it might be nice to have. Remembering that R, it's going to give us the rate, the annual rate, the rate per year, as a decimal, which we would typically report as a percentage, right? So you need to do some alterations there. T is the time in years, right? And so typically it'll give us a decimal, which you might have to kind of massage a little bit if you need it in months or whatever. But in general, I would just accept a decimal version for T. All right, so let's grab some examples here and do some examples. So this is 4.5. Let's do example 148. So example 148, you invested $5,500 1 year ago. Today it has grown to a total value of $5,733.75. What rate of simple interest did you have for this investment, right? And so if I need to find the rate, right, so here, solve for R. Well, I have the principal amount. I also have the future value. Right? And a little bit subtle, but sometimes we'll need to dig a little bit. We have the time, right? The time was 1 year ago. Okay, so the time it's sat there is just T equals 1, right? And so here this becomes, so P is 5,500, T is 1, right? Subtle, but it's there. And then the future value is 5733.75. Okay. So what I want to do, and you can double check, right? I'm not going to use this R formula, even though we just derived it, but for some more practice, I'm going to put it into this original formula and then rearrange and solve for R, right? And so I know we're all a little bit different in how we like. So some people like to have all the formulas worked out and then you can just grab whichever one you need. For me, I like to have as few formulas as possible and then I just derive the ones that I need, right? And so this is the only formula that I need, and then I can massage it to be what I want to solve for, right? In this case, I want to solve for R. So whichever way you want to do it, right? If you want to go straight and use this R as soon as you identify that I need to solve for R, you can go straight to here if you want to. But I'm going to just start from the original function. So I have the future value is P times 1 plus R times T. I could draw a timeline here, but this is such a basic situation where 5,500 grew to 5,700 in a year, and I'm solving for R. There's nothing, a timeline here wouldn't really help me visualize anything. So I'm not going to do that. But later on, we'll want to use timelines, but not for simple things like this. So now I can just plug in the values, right? Kind of a plug and chug situation here. So 5733.75 is 5,500 times 1 plus R, which is what I'm solving for, times 1, right? T is 1, making things a little bit easier. So if I have to solve for R, then of course, same procedure. I need to divide both sides by 5,500. So I get 5733.75 divided by 5,500 is 1 plus R. So getting R on its own, I need to subtract 1. And so I'll do 5733.75 divided by 5,500 on the side here. So R becomes 1.0425 minus 1. Okay, I did do a kind of I pulled a fast one here. This simplifies to 1.0425, and then I also subtracted 1, and I did the revolving door thing. Did 3 things in one move. Crazy, right? One thing you want to make sure is that we're used to seeing interest rates, you know, from kind of 1%, 2%, 4%, 7%, maybe up to 20%, right? It depends on the problem, but you want to make sure that your answer makes sense here, right? So 1.0425 minus 1, of course, puts me at a rate of 0.0425 or a rate of 4.25%, which seems perfectly reasonable to me, right? And so you just want to check, especially if you forget to subtract the 1, that's going to make a real mess, right? Then you've got a rate of 104%. Probably not, right? Good. So we had a rate of 4.25%. Usually when we report these answers, we give them as percentages, but if you're working in a Moodle quiz, it'll tell you to report it as a decimal or as a percentage, or it should. Okay, Good. So I always prefer to just plug in my values into the original function and then solve it that way. Right. Same thing with the next one. Oh, I do think this question itself is really funny. Because my parents have neighbors named Wayne and Janet, and so it's for me it's just really funny. And sometimes they call each other Wayne and Janie. So Janie borrowed $15,000 from the Bank of Wayne, on November 5th, 2001. Okay, so it was a while back. Why did she need $15,000? Well, it was for a new necklace. She had to borrow the money. What a silly question. The Bank of Wayne charges 7.45% simple interest. Okay, so again, just kind of highlighting for the future when we have to decide if we have a simple interest problem. Well, simple interest, okay, it's right here, smack in the face. This is a simple interest problem, right? That's all we're dealing with so far, but something to look out for. So interest accumulated amounted to $1,534.67. And then on what date was the loan repaid? Because there's a lot of components here. Okay, so she borrowed $15,000 for a new necklace. And by the time it came to pay this back after a rate of 0.0745, she had accumulated interest charges of $1,534.67. What we're going to do is we're going to convert this to, well, what does that mean? So how much did she have to pay back on the repayment date, right? And so here we know, and maybe I'll give myself a little bit more room here. So we know that P is $15,000. November 5th, 2001 is what? That's my date one, right? That's when she borrowed this money. So that's when the clock starts, right? So here, I'm gonna write date one is, and I'm just gonna convert it to that month, dot, day, year format right away. So November is 11/05/01. Item, necklace. The Bank of Wayne charges a rate, so R is 0.0745. And the amount of interest, which is denoted by a capital I, is $1,534.67. That's all the information that I have. But then we also want to find date two, right? So on what date was the loan repaid? Okay, so here, find date two. So we'll have to use our days between dates calculator, which means we need to know the number of days that she borrowed this money for. Okay, so we have a couple of ways to solve this problem, right? You know that I equals PRT, and then you have P, you have R, and you have I, and you want to solve for T eventually. So that's one way that we could do it. But just to get in the habit of using the future value formula, I'm first going to find the future value by adding P and I. Okay, so that's where I'm going to start. And I encourage you to kind of approach this question how you would kind of intuitively, and then just make sure that we end up at the same answer. Because like I said, there are lots of ways that you could kind of go through this problem. For me, I know that the future value is p plus I. So the future value then is 15,000 plus 1,534.67. So 16,534.67. I know. Are you impressed I did that in my head? Probably not. I am. Wow. Okay, so now I have my future value. So now what I'm going to do, just for some practice with the future value formula, is I'm going to say, okay, well, the future value is p times 1 plus r times t. That's all I have, right? I need to find, so if eventually I want to find date 2, I need to find t in days, because remember, as long as I have two of the 3 inputs for the days between dates, I can find the third, right? So if I have date 1 and I have the number of days, I'll be able to compute date 2. Okay? So we need to find t in number of days to use days between dates. Okay, so that's going to be my first stop. So my future value I just found was 16,534.67. My p was 15,000 times 1 plus r is 0.0745 times t. Squeeze it in there. Same idea, right? I need to get t on its own, which means I need to divide both sides by 15,000. So I get to 6. Sometimes I say numbers incorrectly. Often I say numbers incorrectly. 16534.67 divided by 15,000 equals 1 plus 0.0745 t. So what I'm going to do is I'm going to compute this division first, and then I'm going to subtract 1. So then I get 16,534.67 divided by 15,000. I get 1.102311333, repeating. Make sure you keep all your decimal places, whether that means storing that value, right, or just keeping it on your screen if you can. It doesn't matter to me. It's just you have to keep all your decimal places. Minus 1 is 0.0745 times t. So I'm going to subtract 1, and then I'll switcheroo these so the t is on the left-hand side. I'm going to keep it multiplied by 0.0745. T is 0.102311333, repeating. Mostly because I've got a page break here and I just want to remember where I was here. Then I'm going to divide both sides by 0.0745. So t becomes 0.102311333, repeating, over 0.0745. So divided by 0.0745. T is 1.37330648 years. right? Remembering the units for T is always in years, right? And so now, okay, 1.3733064888, probably more decimals, I just don't see them. Years is how many days, right? Because I need to be able to find the number of days using the days between dates calculator. To use days between dates, we need to convert this to years. Or sorry, convert this. I'm so used to going the other way around. Convert this to days. Right, how many days is that? Okay. So if I have 1.37 years, there are 365 days in a year. So what I'm gonna have is I'm gonna have, okay, well, T becomes 1.37, and make sure you keep all these decimal places. 137.33064888 years. How do you do these conversions? Well, I want to cancel out these years, so I'm going to multiply by 365 days, which is the units that I want, over 1 year, right? 365 days per year. And that's how I'm going to be able to cancel the year. That's technically what's going on. I think if you just take a step back and you think about how would I solve this, if I told you 1.5 years, how many days is that? You would probably take 1.5 times 365 to figure out how many days there are. Same idea, right? So, or you're doing the exact same thing, just with this little kind of weird decimal. So times 365 days. So now T is, so times 365, I get T must be 501.256868 days. However, right, we've seen this problem before where, okay, well, can I wait a quarter day? No, not really. I need to take it for 502 days, right? So even though we wouldn't round up to 502 kind of naturally, if you think about what this means, right, in order to pay off a loan, then we would need to go for 502 days. So T must be 502 days, round up to pay off the entire loan. Right? So just to be safe, we're going to use 502 days. So now, in terms of my days between dates calculation, so same thing that we have been doing, right? So I'm going to have date 1, date 2, and the days between dates. This is the first time that we're calculating something other than the days between dates. So now I'm going to put a little star by date 2 because that's the one that I want to solve for. So my days between dates is 502 days. And date 1, when did she borrow this money? Was 11/05/01. So November 5th, 2001. So 11/05. So now let's use our calculator, right? And so now I'm going to enter date 1, and then I'm going to scroll down to the days between dates and tell it to, so force it to be 502 days. And then remember, you have to hit enter to store it. And then I'm going to go to date 2 and compute that. So I don't think we've done one like this before, but I have mentioned, you know, you can, as long as you have 2 of the 3, you can solve for the third. So I'll go to my second date menu again. Date 1, I have to change it to November 5th. So 11/05/01 because it's 2001. Fun. Remember to hit enter, otherwise it won't store it. And then I'm going to scroll past date 2 because that's the one I'm going to go back and compute later. And the days between dates, now I'm going to force it to be 502. Notice how there's no equal sign. Days between dates, usually it says equals. So until I hit enter, it won't store that. So then I hit enter and now it says days between dates equals. So you want to make sure that you are able to kind of pick up on when it hasn't stored stuff. So now it's stored it. And then now I can go back to date 2 and now I can compute it, right? You can scroll up, make sure date 1 is good. Days between dates, it's stored as 502. Okay, good. So now I go to date 2 and I hit compute, CPT compute. It was a beautiful Saturday, March 22nd. Hey, that's my dad's birthday. 2003. Yikes. Took her a while. So the answer here, and I'll do a different color, was Saturday, March 22nd, 2003. Beautiful sunny day. Just for fun. Okay. Let's take a quick break because that was a big question, right? So let's take a quick 5-minute break and I'll see you back here at 11:08. How weird is that? A break until 11:08. So we're back. Okay. So we've only done one each of solving for R and solving for T, but I've kind of showed you the ropes on sometimes you'll need to kind of take it one step further. So it's not just in years solving for T, but you have to solve for maybe the days or the days between dates or months, depending on what the question's asking for, right? So of course, these will kind of crop up in the rest of our calculations. So I'm going to keep going. And let's talk about, so section 4.6 is called equivalent payments. Now, if you imagine, so you go to a couple of different banks, for example, and you say, okay, I want this amount to grow to this future value. Okay, so then they'll offer you a rate and some amount of time, and then you can go through and you can compare those rates and potentially the amount of time. Usually we specify the amount of time, but just to kind of keep it open-ended. So let's see here. So section 4.6, I'll start on a fresh page here. 4.6 is on equivalent payments. Oops. Okay. So two payments that end up at an equivalent future value are called equivalent payments. Okay, so two payments, and I'm just grabbing this official definition because I think it's pretty clear, that enable you to end up with the same dollar amount at a later date. So with the same dollar amount at a later date are called economically, in brackets because we don't usually say economically, they're called equivalent payments. Okay. So if you're able to end up at the same future value, then we say that these two payments are equivalent. So there's no formulas or anything like that. It's more of a concept that we need to be able to apply. So let's grab an example, and hopefully my examples kind of follow the good. So example 159 is the next example on that handout. So that is what we will do. And I think there's maybe something similar on your assignment 5. So definitely didn't have, you had all the tools, you had the formula already, but it was kind of hard to piece together since we haven't covered any of this. So a particular investment pays $800 payments for 8 and 12 months from now, right? So $800 and then $800 and then $800. What's the most an investor should be willing to pay for this investment today? So today, if money earns a rate of return of 6%. And then, so use today as the focal date. So the focal date is going to be where we draw all our money to. Okay, so first I want to just highlight the focal date is going to be, now let me just, focal date is the date we draw all our money to, and by that I mean all the arrows should go to the focal date. So the date we draw all our payments to, which mean that all arrows should point to the focal date on our timeline. Okay, so what that means is, okay, well, today has to be on my timeline, and then there's some important dates like 4, 8, and 12 months from now. So it looks like when I go through and read the problem, it looks like I have 4 dates that I want to distribute on my timeline, and I want to distribute them evenly. So my timeline here, right, as soon as you have a problem that's a little bit trickier like this, multiple payments, whatever, your default should just start with a timeline. Try to figure out how to put this information onto a timeline and just kind of summarize it. So, and then I'm going to put, have 4 time pieces on here. There are cases where I'll read the question first and I think there's 4 pieces, but then when I try to put the information together, I actually need a 5th one or something like that. So just kind of be flexible, right? Maybe draw a couple of timelines for each question just to play around with it, right? The more you draw, the more you'll, the quicker you'll be at recognizing, oh, I need 4 time points. Oh, and then I need this and this and that. So, okay, so we're gonna start here today, which we are calling our focal date, mostly because it told us to. Right? So we haven't used that terminology before because we haven't done a lot of timelines yet. So when I give you the focal date, it's supposed to be kind of a nice, making it easier for you because now I know that all my arrows have to go to the focal date. So we don't know for 8 and 12 months from today, but that's okay. I can just put 4 months, 8 months, 12 months up here. So I have 4 months from today. And then I have 8 months from today and 12 months. So if you're given months, I don't want you to worry about kind of finding the days between dates. You can just use the months. Okay, so then remember, I want to put the dollar amount underneath, right? So underneath 4, 8, and 12, I'm going to put 800 each. Okay. So, okay. The question asks, what's the most an investor should be willing to pay for this investment today, right? If money earns a rate of return of 6%. So what does that mean? It means that, okay, so today he went to the bank, or we went to the bank, let's say. So we went to the bank and they said, oh yeah, we're gonna give you $800 in 4, 8, and 12 months. And then they said, but you have to pay us some amount, right? And so we need to figure out, well, at what point would I just be better off to just take my money and deposit it at 6% and not get these multiple payments, right? And so how much this payment stream, this is called a payment stream, and you can kind of see how it's a payment stream, right? How much is this payment stream worth today, right? And so what we want to do is we want to draw this, and so this is what I mean by draw the payments. I want to draw this payment $800 back to today, right? Today, $800 4 months from now is worth less than $800 today because I'm earning interest, right? And so same thing with $800 8 months from now, that's worth less than $800 today because it's after interest, right? Same thing with this $800. So to show that, I'm going to draw arrows bringing these payment streams, and this is where I draw my fingers, so a finger for each 800, and then I just kind of draw them backwards to today, right? And so you want to make sure that your arrows kind of look nice and clean, and so I usually draw kind of like this. So I start at the closest one. And this is going to be worth some P1. Okay. Remembering where we started today, we said, okay, the present value, or the P, is always on the left-hand side and the future value is always on the right. So even though this arrow is going backwards, right, P is always to the left and the future value is always to the right, right? So all of these are going to be future values, right? And so when I draw these back, I have to draw them back and they're going to be P's. This is very similar to that big problem that we had to finish off from last day, right? Where we were finding the future values. And so now I'm finding the total present values. P2, let's call it. And again, I want to use subscripts just to keep track of what's what, right? What belongs to what. It's easy because each of these are the same dollar amounts, so that makes it a little bit easier. However, the length of these arrows are not the same, right? So that's the only thing that's going to change, because it seems like they all have an interest rate of 6%, right? So before I kind of forget it, how about I jot it down somewhere here, R equals 0.06. Because it's the same for all of them, so I'll just kind of have it with my timeline. Okay. If I add up these present values, or these principal amounts, that's the total value today. The total value today. Okay. And that's what we want to find. How much should someone be willing to pay for this payment stream? Well, they shouldn't pay more than this, right? They shouldn't pay more than what it's worth today. Ideally, you would be able to get it for less, and then who knows. Um, remembering that we need to put the t on each of the arrows, right? We use the arrows to show the t. So T1 is 4 months. If I have months, I'm just going to take 4 divided by 12 because t still has to be in years, right? 4 over 12. T2 is going to be 8 months, so 8 over 12. And then T3 is going to be 12 over 12. Okay. Looks like I have all my information that I need here, right? I see that I'm going to have to solve for P 3 times. So in this case, it might be best to just solve for P initially. So here, in terms of my work, I'm going to find that the future value is P times 1 plus R times T. So then if I'm solving for P, P is the future value over 1 plus R times T. Now I'm going to go ahead and just use that instead of rearranging all of my formulas, which I can totally do, but just a little bit lazy. So I'll start on a fresh page here. P1 is, okay, so now I'm just focusing on P1. P1 has a future value of 800. R is 0.06 for all of these, and T for P1 is 4 over 12. So I'm going to solve that here. 800 over 1 plus 0.06 times 4 over 12. Just like before, I need to simplify this 0.06 times 4 over 12 before I add it to 1, and then divide it into 800. So what I get is and I'm going to try to save a little bit of work here, not show as much. 0.06 times 4 divided by 12. Oops. 0.06 times 4 divided by 12 is 1 over 50, so 0.02. So I get 1.02. 800 divided by 1.02. Like I said, I'm kind of, every calculation that I do, I kind of ask myself, does that make sense? So I am arriving at 784.3137255. That is less than 800, and that's what I'm expecting, right? $800 4 months from now is worth less than $800 today, right? And so in terms of money, we've got 784, oops, 31. And I'll try to be a hero here a little bit, and I'm gonna just do these calculations side by side because otherwise it's a ton of scrolling. So P2, and you're allowed to do the same, is 800 divided by 1 plus 0.06. So now we just do it all over again, 0.06 times, but remembering that the only thing that's changing for each of these is the time. So you want to make sure that you use the correct time, right? 8 over 12 in this case. Times 8 over 12. And so that becomes 0.06 times 8 divided by 12 is 0.04. So this becomes 800 over 1.04. $769.2307692, which in money is $769.23. Does that make sense? Well, it's been sitting in there for longer. It still grew to 800, right? But because it was in there for 8 months, right, I only had to start with 769 instead of 784 when it sat there for 4 months. right? And so they're going to have different principal amounts, because the longer it's been sitting there, the less I had to have to start with. So it makes sense that this P2 is less than P1. And same idea, I'm expecting P3 to be less than 769 because it's been sitting there for a year. So let's find P3 then is 800 over 1 plus 0.06 times 1, right? 12 over 12 is 1. So putting me at 800 divided by 1.06. Oh, I did 1.03. Sloppy. I get 754, which checks out with what I just established, right? It has to be less than 769. 754 is less than 769. So that's good. 0.7169811. In money, that puts me at 754.72. Okay. So now we've been able to find what each of these are valued at today, right? So the total value today is going to be all of these added together. So then the total value today is P1 plus P2 plus P3, which I can just grab from up above here. And that's the benefit of kind of squeezing them. I know it looks a little bit nasty, but squeezing them, it's just easier for the scroll. So 784.31 plus 769.23 plus 754.72. 784.31 plus 769.23 plus 754.72. $2,308.26. So if you went to the bank and they said, hey, if you give us $2,308.26 today, we'll be able to give you $800 in 4, 8, and 12 months from now. And so, okay, fine. Or better yet, right? If they said, hey, if you give us $2,200 today, they're desperate. We'll be able to give you $800 for 8 and 12 months from now. So if you're able to do this calculation, then you would be able to say that, well, yeah, it's worth $2,308.26 today. So 2,200 or 2,200 is a good deal, right? So then you would probably buy into that. You should. That's a really good deal. So that's what we're doing here. We're trying to figure out what's the value of this investment today. Typically, if we're figuring out the value of an investment, we're finding principal amounts. And if we're finding what total loan amounts, then we find future values. So it depends on which direction we're going on our timeline, which you will pick up on. Okay, so what does that mean? It means that this $2,308.26 is equivalent to $800 for 8 and 12 months from now. Right, so 2308.26 is equivalent, or sorry, today, that's important, is equivalent to $800 for 8 and 12 months from today. And that's what we call the time value of money, because over time, right, our money grows, and so that's what we need to take into account with the interest. Because if you just did 800 times 3, that's 2,400, but that's not how much it's worth today. So you want to keep that clear. Let's do another example. I think I have another example here. So let's do example 163. Okay. Now we're kind of getting into the thick of things. Okay, so because there's going to be a lot, this is a big question, right? And so what you want to do is you want to kind of tease it apart and find points on your timeline, draw your timeline, figure out kind of your plan of action on your timeline. And then once your timeline is done, then most of the work is already done, right? Then you just do calculations. So let me just grab it here so I can have the numbers available. Okay. So let's just take it from the top. 4 months ago, right? So that's 4 months in the past from today, right? So let's just kind of, okay, so we need to know that. Teresa borrowed $1,000 from Josh and agreed to repay the loan in 2 payments to be made 5 and 10 months after the date of the agreement. Okay, so in terms of today is not going to be a date that we're interested in, but it is kind of an anchor date because, okay, 4 months ago, and then from 4 months ago, and then 5 and 10 months after that. So what I'm going to do is I'm going to put today on the timeline, even though it doesn't really need to be there, but it just serves as kind of an anchor. So, okay, so she's going to make 2 payments. Each payment is to consist of $500 of principal and interest at a rate of 9% on that $500 from the date of the agreement. So now, today, Teresa is asking Josh to accept a single payment 3 months from now to settle the debt. Ugh, okay, what a mess. What payment should Josh require if money can now earn 7%? Okay, so now there are so many pieces in play here, right? And so you just want to just kind of take a deep breath, figure out your timeline. And like I said, sometimes I'll find, I'll start and I'll try to figure out how many time points to put on my timeline. That's always where I start, right? And sometimes after reading the question a couple more times, I'm like, oh, I need to put another time point on there. That's okay, right? We just need to, see you later. Have a good weekend. So you want to figure out how many time points you have, and sometimes you will need to make adjustments, especially for a hard question like this. Just kind of start over if you have to, right? Okay, so let's try to map out what we know so far. Okay, so we have, I'm going to start my timeline here. Make sure you use as much of your page as possible because we'll need all that space. Okay. So dates that have been mentioned 4 months ago, and then kind of implied from today, but also they're talking about today. She's asking for, okay, so we'll need today as kind of an anchor point. And then she was supposed to make payments 5 months and 10 months after the date of the agreement. Okay, so that's 4 dates that I need to put on here. So let's figure out, okay, and then now she's asking Josh to accept a single payment 3 months from now. So that's a fifth date, right? And here's where I think if you started out with the 4 and started figuring it out and then had to add the fifth date, no harm. So I need to get 5 ticks on here. I've got 2, and then so 1, 2, 3, let's say. Try to do sort of evenly spaced. It's just for visualizing anyways. So making sure that we know that this is today, right? And so it might help to kind of jot down the dates and kind of have them sorted on the side maybe before you start your timeline. I don't know. But so today, and then so 4 months ago is up here. Okay. And if you want to kind of cross stuff off, that's fine. As we go along here, right? And just kind of till you've covered all this information, that's fine. But then we want to make 2 payments, 5 and 10 months after the date of the agreement, just to keep these 3 points kind of sorted out. I want to make sure that 3 months from now, okay, has to fit in on the timeline appropriately. So 5 and 10 months after the date of the agreement. So 5 months would be to here, right? 5 months, but 5 months from the date of the agreement is really just 1 month from today, right? And so here, this becomes 1 month if we're referring to today, right? And then let's just see where we're going to squeeze in. So today she's asking for a single payment 3 months from now, probably here, but let's just make sure. And then the last payment was supposed to be 10 months after the date of the agreement. So that's going to be, yeah, so it all checks out here. And this is what I mean. Don't be scared to draw kind of first draft, second draft timelines, because it's going to take a while to develop that kind of, oh, I need 5 points and they're going to go here and here and here, right? So this length of time is going to be 10 months, but in terms of my timeline, right, referring to today, this is going to be at 6 months. And then she wants to make a single payment 3 months from today. So then this would put us at 3 months. Okay. Okay, so now let's map out what do we have to do here, right? What's going on, right? It's a confusing question, I think, a little bit, because there's a lot going on. So, but I will say this, it will be par for the course for the types of questions that I'm expecting you to do, right? So there's going to be, oh, we borrowed this money and we agreed on this repayment plan, and oh no, something's changed and now we want to repay it like this. Big questions, but we're going to do a lot of them, so you'll be used to it. Okay, so 4 months ago, she borrowed $1,000. So remember, dollar amounts should go below these ticks. So I have $1,000 here, and she was going to make multiple payments, right, to pay off this $1,000 plus interest. Okay, so let's see here. Oh, whoops, sorry. $1,000 was split into $500 and $500. So each of the payments is going to be $500 plus interest and $500 plus interest. So I'm going to change this to be 500, and 500 for a total of 1,000 borrowed. Okay. And I'm just giving myself a little bit of space because it's going to be multiple calculations here. So you can have it up close if you want. But so now, okay, I was going to make, or I guess Teresa was supposed to make her first payment at the 1 month from today mark, right? And then a second payment 6 months from today. So what that looks like is, okay, so she has to pay this $500 plus interest. So she has to pay some future value at 1 month from today. Right? Same thing with this $500, the second $500, she agreed she would pay some future value at 6 months from today or 10 months from the agreement. Now, to keep these separate, I am going to use little subscripts. So I'm going to use 1 and 2. If you want to get really kind of crazy, you could use 1 for the 1 month and future value 6 for the 6 months. I'm not going to do that. That's crazy. Okay, so this was her original plan. This was the original repayment scheme, which I will highlight here, right, that this activity is the original repayment scheme. Okay. Now, then she changes her mind. Okay, but there's some information on here that we need to kind of jot down before we move on to the new repayment scheme. So each payment is to consist of $500 of principal and interest at the rate of 9% from the date of the agreement. Okay, so for each of these two, the rate is 0.09. And because I've seen that it's going to change to 7, I'm going to put it on each of the arrows just to make sure that they stay the same for each of these. And then for this future value 1, I know that the time is 5 months, and for future value 2, I know the time is 10 months because it's the length of the arrow, right? Not necessarily the time points on our timeline. So T here is 5/12, and T for future value 2 is 10/12, right? The length of the arrow. Okay, so now, all right, we've got a lot of information down here. We can do these calculations, right? Finding these future values is not hard. We have all the information that we need, so we could solve for these amounts, okay? But just to get the whole question on paper, let's keep going. So today, right, so here we are today, Teresa's asking Josh to accept a single payment 3 months from today, okay, to settle the debt, which means that what's going to happen is essentially, and we've got this twist of the rate changing to 7%. So really what's happening is she's going to have to take out another loan on this future value at 7% for 2 months, right? But then she's also paying off this future value early, right? So now our focal date becomes the 3-month mark, because our payments have to go to that 3-month mark. And then we'll be able to say, okay, well, how much would these 2 individual payments be at the 3-month mark? Okay, so for kind kind of lack of time, let's find future value 1 and future value 2 so that we can pick up kind of a little bit quicker next day. Future value 1 is P times 1 plus R times T, right? P for each of these is 500. R for each of these calculations is 9 or 0.09, and T is 5 over 12 for this one. 500 times 1 plus 0.09 times 5 over 12. And I'm just going to do this calculation right away. So 0.09 times 5 divided by 12 plus 1 times 500. So she had agreed to pay 500, oh, I guess I'm not rounding quite yet, $518. Oh, it is. It's just 2 decimal places. And 75 cents. Okay, so that's the first payment that she was supposed to make. Okay. Second payment she's supposed to make, we can find that as well. Okay. Future value 2, and in fact, let me just scoot this side by side here. Scoot. Future value 2. P times 1 plus R times T, which is, again, 500 times 1 plus 0.09 times 10 over 12. Hopefully it's just 2 decimal places again. 0.09 times 10 divided by 12 plus 1 times 500. It is $537.50. Does that make sense? Well, yeah, it does, because here $518 is less than 537, right? The longer you wait, the more you have to repay, so that makes sense. Okay, so what I want you to do on your own is now figure out, so answer the question, right? Now figure out what the future value, so now this future value 1, this $518.75, it's turning into a principal amount if you're talking about the 3-month mark, right? So now you're going to be able to find the future value of that value of this $518, and then you're able to discount this future value 2 to its principal amount at the 3-month mark, and then the total of those would be the single payment that she would be expected to make. So I want you to work through this problem on your own, and maybe try it, kind of start from scratch and see where you get to, and then we'll finish it next day. Because I don't feel like rushing through it. It's not going to do us any good. So if you have any questions, let me know. Otherwise, have a great weekend, and I will see you on Tuesday.
Thanks.